Oh, there we go. Can't say I'm not rusty. Good afternoon. Welcome back to Lockdown Learning. Weekly's feeling a little bit weird to me, but we shall persevere nevertheless. Okay, since we spoke last week, I've done one major thing, which is to stitch the two Git tutorials together into one frankly almighty video. It's huge. It's just over 2 hours long, with a little bit of tidying up, a little bit of editing, a little bit of improving. So there is now a one place to go for that Git tutorial, which I split into two, but I have reunited into one long video. So hopefully that will be useful for some people as a single point of reference. So that's what we've done the last couple of weeks. Today we're going to talk about workflow management. So we're going to look at a workflow management system for bioinformatics, which has been built with bioinformatics in mind, but we're just going to kind of talk about it generically today. And that is Nextflow. So there are lots of workflow management systems out there. The idea behind them tends to be pretty similar. So I'll talk about some of the kind of general concepts behind workflow management and how these kind of systems work. And we'll have a look specifically at Nextflow, how to install Nextflow and kind of how to get started. And what I'm going to do is to start to try and build our own example. I was going to go through the kind of tutorial example on the Nextflow website, but I think that probably with the skills that you've built up so far in Lockdown Learning, you could probably do that yourself. So instead, we're going to try and build our own example, reusing some of the bits and pieces that we've done across the last few weeks, or certainly in the kind of earlier lessons. And I was just trying to do this in the half hour before we started, and I was getting a little bit. I've nearly achieved it, but not quite. So it might be that we get very close, but perhaps with no cigar. But we'll see how we go. And again, I'll be working on it kind of as live, which I know is always fun for people. So let's talk first of all in relatively generic terms about workflow management. So what is it? How does it work? And what are the aims, basically? So we're going to be using Nextflow, which is a workflow management system. There are other options which you may or may not have heard of that are fairly similar to Nextflow in the way that they work, if not quite in the kind of specific syntax of them. So you may also have heard of SnakeMake, which is another workflow management system. It's, as the name suggests, it's kind of Pythonic. It's based on Python. That is the other one that I have used in anger. So I've used Nextflow and I've used SnakeMake. The third one that really is relevant to bioinformatics, and again you may have heard of, is Cromwell. And Cromwell is a workflow management system built by the people who bought you GATK, so the Genome Analysis Toolkit. So Cromwell is kind of built around the precepts of the GATK and for parallelizing those workflows relatively specifically, although it can be used as a more general workflow management system. All of these systems define their workflows in a what's called a DSL, or a domain-specific language, and it's different for each of these. And that's one of the pains about these things, is there could be a single kind of language for describing workflows which any of these systems could consume, but that's not the case. So at the moment, they all have their own workflow management language. Cromwell uses a thing called WDL. With SnakeMake, you build a snake file, and Nextflows is based on a programming language called Groovy, but they have their own language. So although the principles behind each of these systems is the same, the specifics are different, which is why I'm going to focus on one, and I'm going to focus on Nextflow. So what is Nextflow? It is a framework, handwriting for the win, framework for parallel and reproducible computational pipelines. That's the kind of description of it. So a lot of the questions that people ask when you first come to a workflow management system revolve around, well, is this any better than writing bash scripts, basically? Like I've developed these skills. I'm perfectly competent at writing a bash script with for loops in, for instance, for kind of running the same process multiple times. Why do I need a workflow management system when I've devoted a lot of time to learning bash? And the answer really revolves around this word, okay, parallel. And so with a workflow management system, the parallelization effectively comes for free. So I'll try and describe what I mean by that as we go along. But Nextflow and other systems like it come with a number of advantages over simple bash scripting. One of the main ones is this, what's called a high-level parallelization model, where the parallelization is implicit in the way that you build the code, and I'll show you what I mean by that as we go along. Your Nextflow scripts are also going to be portable, they're reproducible, and one of the really nice things is the way in which they're enacted is independent of the script itself. So that really comes into its own when you're thinking about things like where do you actually want to run this compute? So do you want to run this compute locally, or do you want to run it on a high-performance computing server, or do you want to run it in the cloud? And with a system like Nextflow, those three things are completely interchangeable. You just have to change one configuration option, and you can run the same script in those three different places in a trivial fashion. And that's apart from the parallelization, that's the other thing that you get with a system like Nextflow, which is actually really tricky to do. If you're writing bash scripts. The disadvantages of it, as opposed to the kind of computation that we've done so far, you have to learn a new language, effectively a new programming language, to use Nextflow effectively, and that obviously, especially for people fairly new to bioinformatics, is quite a challenge. It's an abstraction layer. Nextflow itself is an abstraction layer between the compute you want to do and the code that you have to write to do it. So you have to deal not only with writing the code to actually undertake the bioinformatics, but you have to deal with this abstraction between you and running that code, which is a challenge, again, especially for novice users. You're slightly hostage to the quality of the documentation. The documentation for Nextflow is improving all of the time. but it's still a little bit, if you can't figure the documentation out to find out the things that you want to do, then it can be slightly problematic. And I guess the other thing, and this is particularly thinking about something like high performance computing, for instance, your Nextflow process. So when you run Nextflow, you start a process. So you start the Nextflow executable effectively, which runs until your pipeline has finished. So that process has to persist for the whole of the workflow, which on local compute is not necessary. With a short job like the things like we're going to do today, that's not necessarily a problem. But on high performance computing, where you might have a pipeline of processes that runs for days and days, that can itself be a slight problem. Those are kind of the disadvantages. But let's think a little bit about how it works. So a Nextflow script is composed of, that's the wrong color, sorry, is composed of a number of processes. Okay, so you define these things in your script, you define these things called processes. A process is defined by its inputs, its outputs, and it's what's called its script. Okay, so a process has these three things. So it has inputs, it has outputs, and it has a script, which helps kind of turns those one things into the other. So takes the inputs and turns them into the outputs effectively. Task dependency, so the dependencies between processes, so how processes link together, is defined implicitly by these inputs and outputs. So what I mean by that is you might have process 1 here, which takes some inputs and produces some outputs. Now, these outputs could specifically be named as the inputs for another process. Okay, so you might have P1 produces output. That output is implicitly required as the input for P2. And so when you run this particular workflow, P2 here will wait for P1 to finish before it runs, because P2 knows that it requires these outputs from P1 before it can run. So the dependencies of these tasks are implicit based on the inputs and the outputs of those tasks. And these things, these inputs and outputs, are referred to in Nextflow as channels. Okay, so the name for these things is channels. Okay, so this is the basic idea behind how Nextflow works. You have processes which have inputs and produce outputs, and these channels link processes together. So two processes may share, so this may have an output channel which then forms the input channel for the next process along the line. And it's those sharing of outputs and inputs which chain together your processes in Nextflow. The other thing that this chaining of channels allows for is the implicit parallelization of tasks. So you might have an input channel which defines 3 inputs. Okay, so you might have this here is a channel, and that channel has has inputs which can be split into 3 blocks. So when this is passed as input into our process. So here's our process. These three inputs get split up into three separate blocks of input. And so we'll have task 1 with input 1, task 2 with input 2, and task 3 with input 3. And then those tasks in turn, so I just move this down. Those tasks in turn will produce 3 separate outputs, which could all then flow into the next process, which could itself have then processed those things independently, and so on. So the parallelization is implicit as well in the way that the pipeline is built. And depending on the architecture that you're running your system on, these 3 tasks could be run as 3 separate processes in parallel. So the parallelization then drops out of the way that you build your Nextflow pipeline. So let's have a look at an example. Let's do 2 things. Let's install Nextflow, and then let's have a look at an example of Nextflow in action. And what we will do in the first instance is we will use the example that is defined on the Nextflow website. So first things first, let's. I'm going to do this in my VM because my VM is Linux. I can do it on my Mac, but it's not so straightforward on a Windows PC. So I just want to make, again, the same as with lots of our lockdown learning things. I want to make this as accessible to everybody as possible without having lots of different hoops to jump through and everybody having slightly different architectures in front of them. So let's do this on our VM. So let's power up our VM. Off we go. So the VM's starting up, and what we'll do first of all is we will take a quick gander at the Nextflow website. So Graham's asking about Conda. It is possible to install Nextflow via Conda, and actually that may make a lot of sense. I'll show you the Nextflow website first of all, and then I'll say why we'll possibly do it using Conda. So I'm just starting up Firefox. Obviously we've got our tabs from previously, so let's just shut those down. And then in this one we will go to nextflow.io, which is the Nextflow website. Which hopefully won't take too long to load. Okay, so here's the Nextflow website. It actually gets you started relatively quickly with the getting started instructions down here. So what it wants you to do is check that you've got Java installed, an appropriate version of Java installed, and then run this command. Now, I don't like commands like this. There's other pieces of software. So Homebrew, which I mentioned in the first of our 2 Git tutorials, is an example of this, which is a software which is installed by using curl. So curl is a library which downloads information over the web, so it works a bit like wget, and we've seen curl in various guises before. So this uses curl to download the contents of a location on the web and pipe it into the bash executable. So that is the bash interpreter, which is the thing which normally interprets our commands at the command line. So essentially what we're doing here is executing an arbitrary piece of code on the internet, which I'm not a massive fan of doing. I will be brutally honest. This is very similar to the way that, for example, Bioconductor used to be installed, where you used to use the source function in R to execute an arbitrary piece of code that you found on the internet. There's nothing to stop this particular website here being hijacked by somebody malicious and injecting some malicious code into your machine via this. So I'm not a huge fan of this kind of mode of installation. But you can, by all means, you can copy this line and paste it into the command line, and that will install Nextflow on your system. We are going to install it using Conda, and as suggested by Graham in the live chat, we're going to install it into our base environment because it will generally be useful across our environments. So let's just install. We should be able to just do Conda install Nextflow, and it should be available in one of the channels that we have added into our Conda environment already. So that makes a decent amount of sense to do that. Okay, so there are our dependencies. We're going to get Nextflow installed alongside Java, JDK, and some other things as well. So off we go. Let's get Nextflow installed, and then we'll write we'll write a script kind of as it appears on the website. So this is just downloading and installing our dependencies. I might do a Conda clean after this because I might be going to be struggling for disk space again. If I was doing this again, I would have made the VM with a slightly larger disk than the 10 gig, because it is a 10 gig with a modern operating system is really pushing it for space. So the JDK is quite big, as you can see here. It's kind of 100 and something meg. So while this installs in one terminal, I'm just going to open a new tab and get ourselves set up. So let's cd into share, and let's make a directory for this. So let's make a Nextflow example directory, and we'll cd into there. Okay, so that's us set up and ready to go. So we're going to write our script. So we're going to use nano to do that. And we're going to call it, let's call it example1. So usually for Nextflow scripts, the convention is to use the extension .nf. Okay, so this is going to be our Nextflow script. Right, Conda is still installing. Don't want to rush it too much. So now Nextflow is installing. So we're getting there. Couple more things to go, I think. There we go. Right, so now I should have Nextflow available in my path. So there you go. There's Nextflow with with some help information. See, Nextflow is another one of these systems which comes with a bunch of commands. So again, very similar to a lot of the software that we've been using over the over the more recent sessions, like SAM tools and BCF tools, and like Git last week as well, and the week before. We have Nextflow and then some commands, and there's a selection of commands there provided for you. So let's start writing our script. I need a hash character. Let's just see if I can type one. No. Okay. Just quickly cat a script from one of the other weeks. There we are. There's our hash character. So we'll paste that in there. Why didn't that work? Okay, I don't know how I turned on line numbers there. Let's not worry too much about that. So the shebang line for a Nextflow script is slightly different to what we've seen with bash scripts. So previously we've done /bin/bash. For Nextflow, it's /user/bin/env and then Nextflow after a space. And that's what tells the system that this is a Nextflow script. Okay, so I'm not going to go too much into the details of what is in this script. I'm essentially copying it from the Nextflow tutorial. So you should be able to track this down on the website. It's in their Getting Started guide, should you want to find the exact contents of this script at a later date. So this is a parameter that we've defined here. So we've set this parameter called str to this value, hello world. We're comfortable with hello world scripts now. So then we want to define our processes. So you define a process by using the keyword process and then the name of the process. So we're going to call this one split letters. And then you define the process between curly braces. So you have an opening curly brace and a closing curly brace. And in between those curly braces, you have the code that defines the process. And a process, if you remember, has three things. It has input, it has output, and it has a script. In the case of this particular process, we don't have any input because the input is going to come from outside the process. It's going to be this parameter here. But we can define some output. And again, don't worry too much about the contents of this at the moment. What this is saying is any file which matches this wildcard forms part of the output of this process. Okay, so that's our output. Then we have our script, which if it's across, the best way of defining it is between these three double quote characters. The reason for that is it just allows it to be, it allows your script to span multiple lines. So you can define a multiple line script here, and this script is essentially just bash. So what the first thing here is doing is printing the contents of our string parameter, our params.str, into a file. So printf prints it into a file handle, and we then pipe the contents of that into this executable called split, which takes the input and breaks it up into chunks. So we're giving it our standard input and we're breaking it up into chunks. I'll show you what split does in a second at the command line. So this will split the input into chunks of 6 bytes. Okay, so we'll get 6 bytes and then 6 bytes. The first 6 bytes of this string is HELLOW space. The second 6 is WORLD exclamation mark. Okay, so this command here splits that string up into those two blocks of 6 characters. And that is our first process, which looks really arcane. And this is one of my bugbears about Nextflow, is that the scripting language is very different to anything that you've encountered before. We're going to define a second process. This one's going to be called convert to upper. And it's going to take the output from split letters and use it as input. So our input here is files called X from letters, and letters is the channel that has been defined as the output of split letters. Okay, so this is, using this name letters here, is the link between this process here and this process here. So this process produces output called letters, and this process uses input called letters. And those two things having the same name creates a link between our two processes. So it creates this invisible link between process 1 and process 2. We need this thing called flatten here for reasons that I don't entirely understand. Sorry, I am not the world's biggest Nextflow expert, I will fully admit. So then we produce some output, which is going to be standard out. So to standard out, we're going to produce a result. And then we want a script, which is the following. We're going to cat $x, that's the variable created here, which is the file. So for each file from the input, this will run with this file called $x. We're going to pipe the results of that cat. So cat here is just a bash command. It works exactly the same as cat at the command line. We're going to pipe that into this second command line tool, which is tr, which is translate. We're going to translate any lowercase letters, so that's all of the letters in the set A to Z, into uppercase letters. So that is the set capital A to capital Z. Okay, so this translates any lowercase characters into uppercase characters. And that's process 2. And then the final thing that our script needs is a way of viewing the results. So we're going to do result.view. Then we need to do curly braces again. It.trim. Again, this is some arcane internals of Nextflow, which again I will admit I don't fully understand. So this is a 28-line script. It's quite long, certainly longer than a lot of bash that we've written over times. It's also fairly arcane. I'll just show you it on the Nextflow website. So here you go. This is the URL, nextflow.io/docs/latest/getstarted.html contains this script. Okay, so you can copy and paste it from here, and there's an explanation of it on there as well. So I'm not doing anything here that you can't get from the tutorial on the internet. Okay, so that's our first Nextflow script. We're going to save it, and we're going to so we've saved that to example 1, and then we're going to run it, but we're not going to run it at the command line like we did to our bash scripts. We're going to use Nextflow to run it, and the way that you do that is you type Nextflow and then run, and then the name of your Nextflow script. So example1.nf. Okay, and this should run our script, and it should run those two processes, and it figures out which order to run them in by the link between the inputs and the outputs. Okay, this has failed. Why has it failed? ln failed to create symbolic link. Operation not permitted. Tip, you can replicate the issue by entering the command. Okay, I don't know why this has failed. That's not good, is it? Because it's the example. It could be to do with the fact that we're running it in a shared directory. I wonder if that's the case. Let me make a directory in my home directory. And let's copy example1 to home/nf test. And then let's cd there. And then we run Nextflow run example1.nf. See if this works. So you can see immediately there's a bit of an overhead that Nextflow adds to any. This is a very simple script. It's doing two very simple things. Yeah, there you go. It worked. Nextflow adds quite a large overhead to it because Nextflow is doing a lot of processing to get this script to run correctly. But it did work there. So the reason it didn't work previously, it will be to do with the setup and the permissions of the share directory, the directory that's shared between our virtual machine and our host operating system. So running it in my home, somewhere in my home directory, which is not shared with my host operating system, meant that it worked correctly. So clearly there's a little bit of an issue there. I'm glad that was the issue because it was easy to fix. So what's happened here is that Nextflow has read that script and processed it and figured out the connections between the two processes that it found inside it. So it found two processes. It found split letters and it found convert to upper. It also figured out that split letters is effectively a dependency of convert to upper, because convert to upper requires as an input the output of split letters. So you can't run convert to upper until you've run split letters. Also what happened is split letters ran, produced the input for convert to upper, and then convert to upper ran. And convert to upper ran in a non-deterministic order. So the order of convert to upper running wasn't dependent on the input. So actually in this case, it ran world first and hello second. If we ran it again, it wouldn't necessarily happen in the same order. It might be that we get hello out first and world out second. That there's nothing deterministic about the order that those things run in. The other thing that I will say that isn't obvious because we're running on a single threaded VM is that if Nextflow had more than one process to run those two convert to upper jobs on, it would have run them in parallel. So on my host operating system, hello and world, the convert to uppers for hello and for world would have run simultaneously on two different processes. On my virtual machine, they run concurrently. They run one after the other because I've only got one thread to run them on. But that is dependent on what Nextflow has available, the resources that Nextflow has available. So if we run this again, we might get the outputs in the other order, or we might get them in the same order. It's not really. There you go. So this time we've got hello world, not world hello, because it's not a given that you will necessarily get those things in the quote unquote correct order. Just to say, there are some other features of Nextflow that make it really nice. So, for instance, you could run this with an option which would be resume. And if you run a Nextflow workflow with the resume option, it will only run things which have changed since the last time you ran it. So in theory, because we haven't changed anything, if we run it with the resume option, Nextflow shouldn't rerun it, although I haven't tested this, so I don't know if that's true. Yeah, so it's used the cached version here. So it's saying it's cached, the results of this are cached, so we're not rerunning it. But again, we've got the outputs, the quote-unquote wrong way round here. But it's running a cached version of that result. If we made a change to our script, so if we changed the convert to upper, so let's nano our example, and let's change convert to upper so that instead of translating our results, instead maybe it reversed the, and again, I'm doing nothing here that isn't in the tutorial on the website. So if we did it so that it reversed the chunk instead, save that and then rerun with resume, the first step will still be cached because it's run it before, but the second step has changed, and Nextflow will work out that it's changed and it will rerun it. And so instead of getting the output translated to uppercase, instead we get the output reversed. But it's still using the cached first step to do that. So you can use Nextflow to resume. We've also defined our string here, our input string, as a parameter. So params.string means something to Nextflow, and we can change it on the fly when running Nextflow by passing the name of that parameter as a variable. So if we instead did it with something different, so my name's too long. Oh well, never mind. Let's do it with that. And that will split still at 6 characters, and it will still reverse it. But it will use the string that I've passed it as a parameter instead of using the hard-coded parameter in the file. So there you go, it's taken my name and it's reversed it. But in chunks of 6. So Simon with a space is one chunk of 6. Then the first 6 characters of my surname is the next chunk of 6. And then we've got an additional chunk, which is just a single L, because my surname is seven letters long. Okay, so that's kind of the kind of parameterization that you can do. There's lots of other features as well, and you can step through the tutorials on the website and discover these features. So you get things like reporting and things like that built in. You can also tell your script where you want it to run a particular process. So you can define things called executors. So at the moment, the executor for my script here is what's known as the local executor. So it's running it on the local compute. But you could set that executor to be Slurm if you've got a high-performance computing system which uses the Slurm queue management system, which we do here at Newcastle, for example. And instead of running each of these jobs locally, each one would be submitted as a process to the Slurm queue. The same for SGE or PBE or LSF. These are all queue management systems for HPC. And you can set your executor to be your favored queue management system. And your job would be submitted to your HPC queue rather than being run on local compute, which means you can develop your workflow locally, test it out, check that it works on your local machine, and then you can deploy it to your HPC. You can also set cloud executors. So you could set an executor to be the Amazon AWS, to be the Amazon cloud. And instead of then executing locally, your job would then go and execute on the Amazon cloud. So that's really quite a nice feature. Those are all helpful and nice features of Nextflow. I just wanted to try and write a slightly bioinformatics relevant example, or at least to try and begin to do that. And so this is kind of what I was trying to get sorted before we started here this afternoon, and I didn't quite get all the way through. So we'll have a go, but it may be that again my best case scenario of one thing per week. We may have come back to this next week to look at this working in more detail, or maybe I will, in between this week and next week, I'll record a little bit extra and tag it on as an extra video, release an extra video that's not based on a live stream. I'll decide what to do between this week and next week. But anyway, let's begin. And what we're going to do to begin with is we're going to copy our example script so that we don't have to do lots and lots of typing again. What I'd like to do is I would like to build a Nextflow script which downloads the data from Uniprot that we downloaded way back in week 3, a long time ago, back in April. And so that's kind of my aim here, is to build a little Nextflow script which achieves what our bash script did in week 3. So let me see if we can begin that process. So here we go. Right. First things first, let's copy. Sorry, I'll see my terminal again. Let's copy our Uniprot IDs from our exercise back in week 3. So we want to copy from home/share week 3. We've got a file which is uniprotids.txt. This is the identifiers for the Uniprot. For the proteins from Uniprot that we downloaded to build our multiple sequence alignment, if you remember way back in week 3, a very long time ago. So in there we have a list of Uniprot identifiers. So what we want to do is we want to read this line by line, and then for each line in this file we want to download the Uniprot entry, the relevant Uniprot entry from Uniprot, from the Uniprot API. So let's edit our example2.nextflow script, and we're going to make some changes as we go. So I'm going to change this params. I'm going to change so that instead of being just an arbitrary string, this is going to be a path to the file that we just copied into our current working directory. Okay, so that's the file. Our split letters process we're going to change. We're going to call it split IDs. The output is actually going to be the same. So we're still going to use split to break our input file up into chunks, but we're going to do it slightly differently, and we're going to call the output something different just so our purpose is clear. Okay, so we're going to call the output, instead of calling it letters, we're going to call it uniprots. I'm not sure if that's a valid pluralization, but there you go. we're going to use split, but we don't have to print R, because it's not a string anymore, it's a reference to a file. We don't have to print this out, we don't have to use printf to kind of print a pseudo file. So instead of this placeholder here for standard output, we can just put the file in here. So we define the file like this. It's $, like in bash, and it's params.id. Okay, so that's our file. But instead of breaking it up into chunks of 6 bytes, we want to break it up by lines, and we just want a chunk that is 1 line. Okay, so that's what we want split to do. So this will break our input file up into chunks of 1 line. Okay, and for now, let's take that and let's do a second process. Let's call it get uniprot. So we're still going to have a file X, but this, instead of from letters, it's from uniprots. We're still going to produce standard output. Okay, so that's going to be our standard output, but our script is going to, we're going to echo X. Let's see if we can do, no, not echo, cat. That should give us the contents of the file X. Okay, so that is, and then the same as before, we're going to view the result just by piping it out using Nextflow's own thing. So this should just print our, just regurgitate our uniprot IDs. So let's save example 2. So this is slightly different to the hello world script that we wrote before, because instead of passing a string, which is then chunked up, we're passing a file, and it's the contents of the file that gets chunked up into bits. So hopefully this will work. Nextflow run example 2. And that doesn't work. Why does that not work? Is it because it's not a file? Okay, hold on. Let's try input file $. Params ID, maybe it's $. Sorry, using the wrong text editor, muscle memory there. Try that. So we want to define it as a file rather than, no, that didn't work. Unknown process directive $. Okay, so it doesn't like the $. There. This is my lack of Nextflow experience coming in here. Let's try that. Yes. Try that. See if that works. No, it doesn't like that either. I know. File well, I might know. File y from params ID, and then it's split $y. So we have to define the file from the string. Let's try that. See if that works. This is where my lack of time to test this before kicking in is really showing me up. Invalid declaration, file y. Unable to define parameter ID, define it using a default value. Oh, hold on. Params.ids. Yes, try again. Fingers crossed. This might work. Might not. Hey, that worked. Ah, that's interesting. Okay. So, it doesn't seem to have read it as a file. It seems to have read it as a string. I wonder. So it didn't split the contents of the file into chunks. It split the name of the file into chunks, which is not quite what I expected to happen. Okay, that's interesting. I might get defeated here. I don't want to be defeated. I want to be able to do this. I'm slightly frustrated that I can't. I'm slightly stuck though, I think. So I think I'm going to have to, let's try one more thing. Get rid of those. And go back to params IDs, see if that works. This is my last throw of the dice, otherwise I'm going to have to give up and come back to this another time. Okay. Okay. Ah, this worked. Ha 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 ha. There you go. Right, so thank you for bearing with me, those of you that are still there. There are still people there. Okay, so we had to define it up at the top here as a file. So this is a type of data. Rather than being a string, it's now a file. And then, therefore, it's understood as being a file here in the script. And so it's passed as a file into our split command. So that splits it up into the lines, and then we just print those lines out. So what I'm going to do, because I am going to leave it there, so what I'm going to do then is I will leave it both as an exercise for the reader and an exercise for myself to figure out in Nextflow how to change the get uniprot process into a process which downloads the FASTA files for those 12 uniprot IDs. So that's going to be my job between now and the beginning and next Wednesday. So I may well start next Wednesday with 5-10 minutes of Nextflow before moving on to the next thing. Okay. So thank you everybody for your perseverance and patience. The Nextflow is this kind of thing which your knowledge of it and usage of it will improve with use. And I guess what is obvious here is that I haven't necessarily used it a phenomenal amount, but it is an extremely useful piece of software. But there's a lot to kind of get your head around. So maybe we'll learn a bit more together next week. Okay. So with that, I'm going to sign off, and I will hope to see you next week. Thanks for sticking around this week. See you again next week. Keep safe, stay well, and see you next time.